all the Form 5 students, welcome to YouTube Free Tuition 3. Today I will focus on integration part 2. So please enjoy my video teaching. Hi, how are you all the Form 5 students? 你好吗? Salam sejahtera. Wanakkam. Okay, welcome back to my channel. Today we want to discuss the area under the curve. Okay, area under the curve is under integration. So for area under the curve, we have different type of the area. So today we will discuss in detail about the area under the curve. So for area, we have area bounded by the x-axis and also area bounded by y-axis. Let's start with the diagram. Okay, look at the y equal to fx. This is the curve, or we call as function, and we have the limit, lower limit x1 and upper limit is x2. Okay, the shaded region is area under the curve. So the area shaded in blue represent area which is positive because it is above the x-axis. So after this, I will show you the formula to find the area under the curve for area bounded by the x-axis and the curve and the limit x1 and x2. So you have to memorize the formula. If you can't memorize, maybe you can refer to the formula list in SPM exam. The formula is given. So let's see. This is area under the curve. Okay, or we call area between the curve and x-axis. So the formula is equal to integrate from x1 to x2 for y dx. Okay, dx means bounded by the x-axis. So in bahasa we say terhadap paksi x. Luas di bawah lengkung dengan paksi x. So the formula is dx, y dx. So please try to memorize the formula so that you can do it fast. So after this, I will show you the example, okay, for the area bounded by the x-axis, or we call as area between the curve and the x-axis. So I will give you example for each type of the area. If area bounded by y-axis, I will give you example for the area bounded by y-axis. Okay, this is the example. Y equal to fx is bounded by the x-axis, so the limit is follow the x1 and x2. If area between the curve and the y-axis, the formula will be integrate from y1 to y2, and the formula now become x dy. Alright, so let's see the example. Find the area of the following shaded regions. Okay, cari luas di bawah rantau berorek berikut. So we are going to integrate the function when we find the area. Okay, after you integrate the function, you have to substitute the limit into the function, and you have to simplify to get the answer. Okay, So let's see how to do example 1. You are having a curve with the y given. So because the graph is bounded by the x-axis, okay, you see the blue region, okay, the boundary means the sempadan is at the x-axis. So we will use a formula. Area is equal to integrate from -1 to 1, okay, for the function. So the function is y equal to 2 minus x squared. So we will use a formula. Area is actually equal to integrate from x1 to x2 y dx, and we will substitute y as 2 minus x squared, and then we will integrate from the limit -1 to 1. The lower limit is -1, the upper limit is 1. So after we integrate the function, okay, we will substitute the limit. Okay, how we substitute the limit is we substitute the upper limit first minus the lower limit. Okay, so after you substitute the limit, you need to simplify carefully in order to get the answer. So please remember, when you substitute the limit, is always the upper limit minus the lower limit. So we will substitute 1 first, okay, then only we will substitute -1. The upper limit is 1 and the lower limit is -1. Okay, so after you substitute, you'll get the area which is positive. Let's see another example. Y equal to -4x plus 3x squared dx. So the area is equal to integrate -4x plus 3x squared dx for the limit from lower to upper, which is 2 to 4. Okay, so we will write integrate 2 to 4, -4x plus 3x squared dx, and then we will integrate -2x squared plus x cubed, okay, for 2, then we substitute 4 into the function, and then followed by -2, and we will solve and get the answer. And then next question is, the function is y equal to 2x plus 3 to the power of 2. So we will integrate the function with the formula area equal to integrate from -2 to 4 for 2x plus 3 square. So we'll use a power 2x plus 4 power 3 over 3, and then don't forget to divide by 2. Then we'll substitute 4, okay, first, followed by -2, and we will solve to get the answer. Okay, the answer is positive. Okay, so please remember, this is using chain rule formula for the area. Okay, now we want to discuss another one. Area y equal to 2 plus 1 over x cubed. So our formula is integrate from 1 to 3, 2 plus 1 over x cubed. So the x cubed, you have to raise the power, become -3, and then integrate 2 become 2x, then x -2 over -2, and the power is negative. Be careful, make sure you substitute accordingly, upper limit minus the lower limit, and you solve to get the answer. So always double check your limit, upper limit minus lower limit. For this one, okay, the curve is under the x-axis. So area is integrate from x1 is 0 to 1, okay, -3 over 2x minus 3 square dx. So you have to use a chain rule for this one. Okay, when you use a chain rule, please make sure you don't forget about dividing the constant in front of x. Okay, So then you substitute the upper limit minus the lower limit and you simplify. Be careful, the value of definite integral for the area below the x-axis is always negative. So you have to make it positive because it's area. Okay, for this one, you have one part which is above the x-axis, so the value for definite integral for the area for the above the x-axis is positive. But if the area is below the x-axis, the value is negative. So you have to use a modulus to make it positive, to convert the area to become positive value. So we say we want the magnitude. Let's integrate from 0 to 0.5 for the 4x cubed minus x dx. So we put the two lines, you see, not modulus, make it positive, plus integrate from 0.5 to 1. Okay, that one is positive. So we will substitute the limit after we integrate. Okay, substitute the upper limit 0.5 minus 0. Okay, and then for the second one we will substitute the 1 followed by 0.5. Okay, then we will solve it carefully to get the answer. So after you complete everything, you have to plus the area. Okay, for this one, for example, the next one, this one is very special, the area between the curve and the y-axis. So you see the formula now is x dy. Okay, so the limit will follow the y-axis. So integrate from 0 to 1. Okay, for the function, so we will use a chain rule again. Okay, so we'll substitute the limit, follow the upper limit minus the lower limit. Okay, then for this one also is area bounded by the curve and the y-axis. So area, okay, you have to make x dy, so make x as a subject of y. Okay, then you will substitute into the x, so it's integrate from 0 to 3y, then bracket 3 minus y dy, then you integrate carefully. Okay, substitute 3 into the function followed by minus 0 lower limit, and you simplify to get the answer. Okay, so if you notice that the graph is bounded by y-axis, you have to use x dy. Okay, please pay attention. If the value of the area to the left of the y-axis, then it will be negative. So you have to use a modulus to make it positive. Okay, so this is special. So whenever the area is shaded to the left of the y-axis is negative, to the right of the y-axis is positive. So now we want to integrate from -1 to 3. Okay, so first of all you have to express x in terms of y because it's bounded by y-axis, and our formula will be x dy. So integrate from -1 3 x dy. So we substitute, okay, x in terms of y, and we will integrate and substitute the upper limit minus the lower limit. Upper limit is 3, lower is -1, and we will simplify, and then we will use a modulus to make it positive. Okay, let's see, this one is a combination of the negative and positive, one to the left and one to the right, right? So the one to the left, the area will be negative to the left of the y-axis. The one to the right of y-axis, the area will be positive. So we have to use a modulus to make it positive. It is negative. So integrate from -1 0 x dy is positive, but integrate from 0 1 is negative. Okay, so we have to modulus it. Be careful. So then we will substitute the x in terms of y, and then we will integrate the y, and we will substitute the limit accordingly. So after we substitute the limit, okay, we make sure we substitute 1, okay, followed by 0, and then we will simplify to the simple form. Okay, make sure you do it carefully because it involves negative. So finally the answer must be positive because it is an area.
Here I am with a movie you started, freezing at a